Hey guys, it's Joe here. Today's problem is number of 1 bits on Leetcode. Alright guys, so here's the problem. Number of 1 bits. Write a function that takes an unsigned integer and returns the number of 1 bits it has. This is also known as the Hamming weight of a value. And some notes here that in some languages such as Java, there's no unsigned integer type. In this case, the input will be given as a signed integer type. Should not affect your implementation, as the integer's internal binary representation is the same whether it is signed or unsigned. And in Java, the compiler represents these signed integers as 2's complement notation. Therefore, in example 3, the input represents a signed integer -3. So I'll explain this. Just going through the first example you have here, this number here, you can see that there's 1, 2, 3 ones within its binary representation, and this is 1 plus 2 plus 8, so this is 11. That's what the number represents, and it has 3 ones in it, so we output 3. Here we have one bit inside the integer here, so we output 1. And here in the example 3 that we're talking about, this is represented as 2's complement, so this is going to be our signed bit to denote that this would be a negative, and this is actually going to represent -3. And the answer would be 31, because all 32 bits minus this 1 bit, which is 31, they're all 1. So we would return 31. And so if we take this as an example here, and I will cut this down to 4 here. So what we want to do is find the number of bits that are on here. So if we take the binary representation for 1 here, and we take here, if we AND this value, so n ANDed by the value of 1, so 1 here, then we would get 0, 0, 0, and then 1, because 1 and 1, 1 and 1 equals 1. So we know that this bit here is on. And then after knowing that, we just say like our answer is going to be +1. So our answer is just going to increase, so +1. And we kind of do the same process to find out the other bits. But what we'll do is we'll shift this over to the right. So we'll right shift this. And then after right shifting it, we do the same thing and we find out, oh, okay, this one is also a 1. And so we add 1 again. And then we do the same process. I'll show it one more time. And we get rid of this, and this will be shifted over. And you can see here, this is a 0. Since 1 and 0 is 0, so then we don't add anything here. So let's implement this. So we'll have our integer answer start at 0. And since we have 32 bits, we'll loop for 32 times. And here we'll say that answer is going to be plus equal to n ANDed by 1. And if we get the value 1, like we did below here, we would add 1, otherwise 0. And then we take this and shift it over by 1. So shift it and make it equal to whatever that value is. And then we return answer. And here, I'll just comment all this out so that it compiles. And we can see that everything comes through accepted and submit. And that's it, guys. So yeah, if you want more stuff like this, let me know. Yeah, please like, comment, subscribe. See you in the next one.